Today in Capecchi's Corner, we're going to look at simplifying radical expressions. As we simplify radical expressions, we have to make sure when we're looking at the coefficient and our variables that neither of them have a perfect square when still under the radical sign. So in looking at number 1, we have the square root of 36m to the fourth. So let's first look at our coefficient. Since 36 is a perfect square, the square root of 36 is 6, because 6 times 6 gives us 36. Now when we're looking at the square root of m to the fourth, we're trying to figure out if that's a perfect square, which it is because m squared times m squared is equal to m to the fourth. So that simplifies to m squared. So our final answer is 6m squared. Now number 2, we have the square root of 90, y to the 8th, z to the 5th. Now 90 is not a perfect square, and we have y to the 8th, and then we have z to the 5th. So what I'd like to do is I'd like to, at this point, do two radicals. One that has a set of perfect squares in it, and one that does not. So when I'm first looking at the square root of 90, 9 is the perfect square that divides evenly into 90. So my 9 goes under my first radical, and 10 goes under my other radical. So now let's look at y to the 8th. Y to the 8th is a perfect square because it's an even power, y to the 4th times y to the 4th. So y to the 8th is going to go under my first radical, so I can simplify that. Now I have z to the 5th. Z to the 5th is an odd power, so it's not a perfect square. However, if I take z to the 4th and multiply that by z to the 1st, then I get z to the 5th. Now z to the 4th is an even power, so that is going to be a perfect square. And then I have z to the 1st. So when I simplify this, here's my perfect square set of radicals there. So I have the square root of 9, y to the 8th, z to the 4th gives me 3, y to the 4th, z to the 2nd. And the second radical is one that I cannot simplify any further. So then I have times the square root of 10z. So that's my final answer. Number 3 is a square root of 56a, b to the 10th, c to the 7th. So again, I'm going to set up my two radicals. Just makes it a little easier. The square root of 56 is not a perfect square, but we do have 4 times 14 gives me 56, 4 being my perfect square. So my 4 is going to go in my first radical, and my 14 is going to go in my second. Then I look at a to the first. A to the first is not a perfect square. It's going to go into my second radical. And then I have b to the 10th, which is a perfect square, so that goes there. And then c to the 7th. Now again, I can split that up as c to the 6th times c to the 1st. So c to the 6th goes here, c to the 1st is there. Now I'm going to simplify that. So the square root of 4, b to the 10th, c to the 6th is 2, b to the 5th, c to the 3rd, times the square root of 14, ac. So that's my final answer. In number 4, we have the square root of 3g to the 4th, h, times 3, times the square root of 6g to the 3rd, h to the 5th. So I have a lot going on there. So sometimes it's a little easier if I just multiply everything underneath. Now this 3 is going to go out front. It's already out front, so it's going to stay out front. And then I have 3 times 6, which gives me 18. And then I have g to the 4th times g to the 3rd, which is g to the 7th. And then I have h to the 1st times h to the 5th, which gives me h to the 6th. Now I'll continue simplifying, so this 3 is going to stay out front. I'm going to keep rewriting that so I don't forget it. I have my two radicals. 18 has a perfect square, which is 9, so it's 9 and 2. G to the 7th I can split up as g to the 6th and g. And then h to the 6th is a perfect square, so it's going to go under there. So when I simplify, I have 3 times 3 g to the 3rd, h to the 3rd, times the square root of 2g. When I simplify that, my final step, my final answer is 9 g to the 3rd, h to the 3rd, times the square root of 2g. Now we're going to simplify an expression that has a binomial on the bottom, one of them being a radical sign. So let me just show you what students initially think. Well, they see a square root of 2, and I say, well, I just want to get rid of that square root of 2. So what happens if I multiply top and bottom by the square root of 2? We know we can't have a radical on the bottom in my denominator, so a lot of times students think that this is the easiest way to do it, but it really doesn't work. If I were to distribute this negative 2 to my binomial, I get 5 root 2 plus, and then I have root 2 times root 2, which is 2. So although I got rid of one radical, I gave myself another radical still in the denominator, so that really doesn't help. So I'm going to erase that and start again. So what I actually have to do is multiply by the conjugate, which means I'm going to multiply by the same binomial with opposite signs. So let me rewrite my original fraction. So I have 3 over 5 plus the square root of 2. Now I'm going to multiply by the conjugate, which is 5 minus the square root of 2. So whatever I do at the bottom, I have to do the top. So initially I'm going to distribute that 3. So that gives me 15 minus 3 root 2. Now at the bottom, I actually have a binomial times a binomial, so I'm going to use FOIL. I'm going to write it underneath here to start with. So I have 5 times 5, my first, which is 25. My outside gives me minus 5 root 2. My inside gives me positive 5 root 2. And my last gives me root 2 times root 2, so that gives me negative 2. So I combine what I have. My middle two terms zero out, which is really what I want when I'm multiplying by the conjugate. So I have 25 minus 2, which is 23. Now at this point I can't simplify any further, so that's actually my final answer. 15 minus 3 root 2 over 23. Let's look at number 2. We have 7 over 4 minus root 7. Now again I have a binomial in my denominator with a radical, so I know I have to multiply it by the conjugate. The conjugate of this is going to be 4 plus the square root of 7. So whatever I do the denominator, I have to do the top. So again, I'm going to distribute. So 7 times 4 gives me 28 plus 7 root 7. And then when I use FOIL on the bottom, I have 4 times 4 gives me 16. My outside gives me plus 4 root 7. My inside gives me negative 4 root 7. And my last gives me minus root 7 times root 7 is 7. This zeroes out. So my numerator is 28 plus 7 root 7. My denominator is 16 minus 7, which is 9. I can't simplify that anymore, so that's my final answer. In our last problem for today, we have a fraction that has a binomial on the bottom, but this time instead of one radical, we have 2. So again, we're still going to multiply by the conjugate. So I'm going to multiply the bottom by root 3, this time minus the square root of 2. So again, I'm going to do the same thing to the top. So my numerator is going to stay root 3 minus root 2 since I'm multiplying it by 1. And my denominator, I'm going to use FOIL. So root 3 times root 3 gives me 3. My outside gives me root 3 times root 2, and there's a negative sign there, so that's going to be negative root 6. My inside is going to be root 2 times root 3, which is going to be positive root 6. And then my last term is root 2 times root 2, so I have negative 2. So in the end, they're going to zero out. So I have root 3 minus root 2 all over 3 minus 2, which is 1. So in the end, I don't need that 1 in my denominator. So root 3 minus root 2 is my most simplified form, so that's my final answer.